Great. Thank you, everyone, for joining our session on operationalizing generative AI, a topic you've probably heard quite a bit about over the last 3 days. I hope you're not sick of it yet, so please bear with us one last time. I did actually a quick search earlier this morning about all the sessions this week that tackle this topic from different angles. New products, new tools, new design principles, best practices, security and compliance, and the list goes on. And this just really shows you how fast the field is evolving and that we're all learning and sharing as we go on. And we're here to give you another perspective. My name is Mikhail. I'm an outbound product manager for Vertex AI. I'll be joined on stage later by Chase, our MLOps and pipelines product lead on Vertex AI. And we're excited to have Deb from Credit Karma and Matt from Wayfair to share their journey about their learnings about standing up an AI platform on GCP and Vertex AI within their organizations. Our agenda, I'll keep it pretty quick and do a quick flyby of the themes we've really run into over the last year. I'll kick it to Chase to walk us through an MLOps for generative AI framework, then real-world case studies from Deb and Matt, and close it out to get you to lunch as quick as possible. So let's start with a quick, why are we here today? Gartner's survey, which was almost exactly a year ago, showed that only 4% of enterprise respondents had a generative AI use case in production. Within 2 fast quarters in September, that number more than doubled, up to 10%. And looking forward, Gartner believes that by 2026, over 80% of enterprises will use or deploy generative AI into production. And after seeing all the momentum and all the partner and customer stories over the last 3 years, that doesn't feel like a far stretch, especially for some of the more well-understood use cases that a lot of us are tackling today. So let's quickly go through some of the key inflection points we really ran into over the last year. So first, quick poll with a show of hands. How many of you have used an off-the-shelf foundation model? Almost everybody. So all of us a year ago were pretty amazed by the capabilities of the blue box, a multitask foundation model, and your organization, your team didn't even need to pre-train that model. That came pre-trained by research teams of model builders using the data in the dotted left circle. And most of us became model consumers. And all developers really gained a lot of these AI superpowers. Call an API with a natural language request and get a great response. And a lot of our work earlier last year was getting the most out of the data in the dark gray box in the context window. Since then, how many of you have fine-tuned your model on some of your data? A little bit less, but still quite a bit of you. So towards the middle of last year, fine-tuning these models for your specialized tasks became really a common workflow with more targeted evaluation criteria. In the diagram, you now start seeing more of the gray, the dark gray circles representing your data, your enterprise data popping up. And we all started curating high-quality tuning data to improve model performance, improve latency, and improve cost. And this model customizer workflow really started resembling a lot of the traditional data science workflows. So we added in the bottom here again, model customizers resembling the data science workflows. And really, over the last year, we have seen these data science ML teams become very critical in curating, evaluating these pipelines. Next trend we saw was really augmenting these models with not just small curated data sets, but with your internal and external data systems. Even more of the dark gray boxes with your enterprise data really comes into the mix. Last poll, how many of you have put together a RAG pipeline within the last few months? Pretty amazing, actually. Quite a lot of you here. And it's pretty exciting because I would say most of us, including me, 1.5, 2 years ago, did not know what RAG was, did not really know what a vector database was. And now we're able to really stand up a RAG solution fairly quickly. And we've really moved to understanding how to evaluate, optimize a lot of these workflows, and whether it's fine-tuning, RAG, or other techniques to get the most out of these models. So again, architecting data pipelines around these models is becoming a very common pattern. RAG is one of them, but also function calling to interact with data and applications, setting up batch pipelines for certain use cases, accessing tools like code interpreters, and using grounding to reduce hallucinations. So the role that we've actually seen very successful in this additional workflow as model augmenters in building and scaling these data pipelines, again, is the data engineers. And I've added another persona at the bottom, model augmenters, very similar, starting to resemble the data engineers. So we've seen this ecosystem evolve from just models to data, tools, and apps. And moving forward, a big theme of this week was really the next frontier of what agents can do. And you can imagine as organizations move from their first use case to their 5th, to their 25th, getting to the hundreds, governance, security, auditability, monitoring all becomes critical as more and more of these pipelines enter your enterprise. So with this, we are seeing a few fundamental principles emerge as more and more GenAI use cases make their way into production. Number one, adopt a platform. Models will continue to get better. Just this week, Claude 3 on Vertex, new Gemini variants. Mistral even released their new model. So the best future proofing you can really do is really adopt a platform and get familiar with workflows across prompt management, evaluations, tunings, and governance. 2, while you're likely not training your own generative AI models, you still get the most value from these models using your data, and building these data connectors, pipelines, and tools around the model is becoming a very priority use case. 3, it's clear that the developer and the AI engineer are really driving this field. But as I walk through those 2 model customizer and model augmenter personas, really leveraging existing data science and data engineering skills, augmenting a lot of the developer skills really becomes very important. And number 4, which is my tee up to pass it over to Chase, is that MLOps comes back into focus. So I'll hand it over to Chase.
Thanks very much, Mikhail. Hi, I'm Chase Lyall, Product Manager for Vertex Pipelines and Monitoring. And I'm super excited to talk to you about MLOps for generative AI today. Actually, I understand there's some Mandalay Bay scouts somewhere. We might try to make this into an MLOps residency, so come by next week. But first, I want to ground us on what I mean when I say MLOps. I think MLOps is used in a lot of different contexts today, all over the place. And when I say MLOps, I succinctly mean a set of people, processes, and tools for delivering ML applications to production rapidly and reliably. And what this requires is continuous integration and delivery of your data pipelines, your model training and tuning pipelines, and your application workflows, such that they're all running continuously in production and can be updated iteratively. And arguably, this was started at Google back in 2015 with this paper. So I'd love to address an elephant in the room. Why are we not discussing LLM ops? Well, 1, these models are multimodal, so we think language is a bit limiting. And 2, computer vision and natural language processing have been common data science practices for a long time. And what we have found is that the systems for developing, evaluating, and monitoring these applications are very much shared with your predictive AI MLOps practice, and is actually pushing us to strengthen and make these practices more robust. So what's blocking enterprises from production? Well, to put succinctly, it's trust. Trust that the model's going to do what you want it to do. Trust that the model's not going to do what you don't want it to do. And then trust that at the end of the day, you will see a return on investment. So how do we build trust? Well, I'm training a couple of large neural nets at home, my 2-month-old and my 3-year-old. And establishing trust with my kids is the same way you establish trust with these models. First, you have to set expectations and communicate them. And then second, you actually have to evaluate them against those expectations. It's not enough just to set them. You have to continuously test them. And so you've heard of test-driven development. Today, I'm very much going to be advocating for evaluation-driven development, that before you implement change into your system, you know what change you're trying to see and how you can measure it, because these are very non-deterministic systems due to temperature. And if you can't measure an improvement, then you're going to struggle to improve it, and you're going to get kind of lost. So let's see how MLOps can help us build trust. We're going to build up this framework incrementally. We start with continuous improvement. So MLOps is a journey of continuous improvement. This is influenced by cycles like plan, do, check, act, like Six Sigma, like design thinking, where we are always being inspired by ideating and implementing change. Underpinning all of this is governance. Governance is where you actually establish the expectations and then enforce automation, build automation to enforce them. Your developers will start with discovery, where they are inspired by what others are doing, and then they actually look to incorporate what others are doing into their own practice. Then they might move on to data curation, where they're actually building out ground truth such that they can know what they're training and evaluating against. Then they might move on to developing and experimenting, and this is where you're often going to now be picking a model off the shelf and evaluating it against your own ground truth and data to see if it works for your needs. And historically, we talked about training first. Now we just go into evaluation. And then you'll want to release, validate it, and deploy it into production. And then eventually you're in production, and you have this feedback loop by which you can get production inferences and feed that back into your evaluation and tuning corpus. And then you might say, this model's great off the shelf, but how do I improve it for my needs? And you have two options. You have customization, where we're talking about actually adjusting model weights. So historically, we've talked about training and hyperparameter tuning. Now we're talking about supervised fine-tuning and reinforcement learning from human feedback, where you're actually optimizing the weights of the model for your needs. And then you might want to also augment them online. So these models are zero-shot, few-shot learners, and so you can augment them with all sorts of cool capabilities, such as simple as a reasoning loop like reflection, can make a small model perform as well as a larger model, give it access to tools, give it access to your knowledge base through RAG. So augmenting is definitely the new hot space that we're talking about a lot, and that's where you're actually building out your end-to-end agent. So now let's peek under the covers a bit. In this view, you can see a bit more detail of what I mean in each of these sections. And in the heart of this system is the evaluation loop again. I'm very much advocating for evaluation-driven development. You need to know how to measure the change you want to see. And so start with your evaluation criteria. How are you going to measure whether your model improved in coherence or factuality or safety? Once you've moved on from your experimentation, then you'll actually curate your data set, and you'll do these hand in hand, switching back from evaluation to curating data, such that you have ground truth to evaluate against. And then hopefully here you can see that your data pipelines, your model training and tuning pipelines, and your augmentation pipelines, your application workflows, are all feeding that experimentation flywheel and then getting shipped to production. So hopefully this is a pretty clean view of MLOps. But I must apologize. I am oversimplifying here. I haven't touched on how you roll out across dev, test, and production. I'm not touching here on how you deploy in multiple regions, such that you have disaster recovery for each of these workflows. And I'm not touching on here how you have to build this for each separate business unit so that they're isolated and you don't have data leaking or artifacts leaking across those business units. And you might say, Chase, I don't think you're oversimplifying at all. This looks like a lot. And I have a couple things to say to that. Don't worry. We're going to go through this one at a time and look at each of these in a bit more detail. Secondarily, Google Cloud and Vertex AI has a lot of point solutions that can help you along the way. And then third, you should definitely try to start incrementally. And incrementally generally means you delegate trust first to others. So what does delegating trust look like? Well, delegating trust means starting with use cases where you keep your experts in the loop. You already have trust in your people, so you can build out a lot of experience building use cases for those people. Inform your knowledge workers, or bootstrap your creatives and code. And that way, you don't have to have as robust of an evaluation suite to build trust in your model. You can build trust in your people and delegate to them. And then eventually, once you have trust in that application, you'll have enough confidence to move on to an external application. And that generally looks like a read-only use case, a low-risk use case, that is well-guarded within a specific task. So that task might be well-guarded around your product catalog or your knowledge base. But this way, you can build up trust slowly, and then once you have enough confidence there, eventually you'll be running it with external agents outside. And this is where you'll see the most value, but also the most risk, right? Because you might potentially get a bad newspaper headline if you're not careful. So now let's dig into each of these pieces one at a time. I'm going to start with the development loop, because that's generally where your developers, I think, should start when we're talking about production ML. And of proof of concept, they might start in model discovery, or they might start in customization and augmentation. But in production ML, when we're talking about production, you have to be able to continuously evaluate and validate these models before you can actually deploy them safely. When it comes to experimenting on these models, it's important to be task-specific with your evaluation criteria. What is good for Q&A will not be good for summarization. What is good for summarization will not be good for content generation. So it's generally helpful to have metrics that are task-specific. And Vertex AI this week released a metric suite by which we give you some pre-built metrics for quality of summarization, quality of Q&A, and quality of text generation. And then also safety. So you can see how we're giving you a lot of capabilities to evaluate your generations along those dimensions of concern. Common method for evaluating these models is computational. So this is where you are writing ground truth, and then you're comparing the model's generation to your ground truth statistically. And you can use a simple means as bag of words or TF-IDF, or you can use more advanced ones like we offer Rouge, LSUM, and Blue to compare what the two generations, how they differ. This doesn't scale, though, because you have to write a ground truth for every prompt. So eventually, you want to move on to auto-raters. This is where we're using large language models themselves to rate along our dimensions of concern. Again, quality, like coherence, fluency, and images, you might think sharpness. And then safety attributes as well. And then lastly, the most important evaluators are actually your humans. These humans know everything best, and so it's important that your evaluations are understandable, explainable, and can be escalated to humans when there's low confidence in their results. And additionally, I think it's important when we're talking about the experimentation loop that we focus on keeping it simple. These are very non-deterministic systems. As soon as you start training a lot of them together as agents, you're going to find that you have maybe 20 or 30 models chained together. And if you have temperature in a lot of those different models, you're going to get very non-deterministic results. So it's very important that you keep it as simple as possible and understandable as possible, such that whenever you add change, you know that you're making forward progress. Now on to data curation. With data curation, we definitely recommend you start with your evaluation set. As I mentioned, test-driven design. It needs to be high quality and novel. So it needs to be representative of your business. And therefore, it's often going to be authored by your business experts or linguists. Don't give it to your developers to write prompt generation pairs unless they're business experts. It definitely needs to be done by business personas. And eventually, you want to scale out. And there's some cool ways to scale out. There's external labelers, which we've had for a long time. We have a partnership with Labelbox, by which you can quickly get external labelers to write generations for you. And now with LLMs, we can also author data synthetically. So synthetic data is a great way to prevent overfitting when you have a small data set. Synthetic data, you can have an LLM rewrite your prompts with different vocabulary such that you can get the quantity you need from a very small set of high quality and novel prompts. And then it's always important to finish that flywheel of production back to your development. On the discovery side, I will say start with a large model first. You're trying to build trust in the quality and safety of your application. It's going to be much easier if you build upon the high quality and safety of the larger models. And then you can always work down, right? You might have business needs that are driving you for lower latency, lower cost, or maybe higher quality within a specific domain where you have a large evaluation and tuning set. But when you start with a large model, you can see those business needs arise, and you will also know what to do next. It becomes a lot more clear. I'll also say that most enterprises are using models from many different publishers. So when you're validating a model garden like ours, it's important to look for all the concerns you have around quality, safety, and then also accessibility to a lot of different models. You don't want vendor lock-in. So it's a balance of highly curated, quality, and safe models, but also reach. And that's why we offer Anthropic models. We offer a lot of open source models through our Hugging Face integration. And then I'll also mention that these models are always evolving. Just looking back at recent history, we've seen that the architectures evolve pretty drastically about every 1 to 2 years. It might slow down at some point, but then even within the existing architecture, we've seen new versions about every 3 to 6 months. And so you have to build an evaluation suite by which you can quickly uptake that change into your system. Even if your system's not changing, you can expect the models around you to change. So you want that evaluation and release validation cycle such that you can get that change into your application. And it's always important to remember that the models we use today are going to be the worst models we use tomorrow, right? Everything's always improving, and you want to be able to incorporate that change into your system quickly. And lastly, on the discovery side, I'll mention that copyright indemnity differs quite a bit by publisher. Some model publishers, like Google with Gemini, will indemnify you against copyright concerns in our pre-training corpus. Other models, publishers might ask you to indemnify them. So there's a different risk in terms of copyright there. On the release validation and deployment side, I'll mention that there's a bunch of information that you'll want to incorporate as far as safety, as far as reciting potential copyright concerns of reciting from the pre-training corpus. As far as hallucinating, technically every generation is a hallucination, but sometimes it's not bounded in fact, right? So you have to implement systems by which you ground it into your truth. It's not the LLM's fault that it has a lot to say. You just have to make sure that it says what you need. There's the risk of breaking guardrails. This is where they might override your system instructions with their own, or potentially a tool might override the user query or system instructions with its own custom prompt. And then even nefarious users might actually write into the web some pre-training data that a model publisher might incorporate into their pre-training set that could potentially poison generation somewhere in the model. So all these safety risks have to be validated, and that's where it's helpful to partner with a large publisher who's taken a lot of these things into concern, and then building on top of that. On the monitoring side, I will say traditional observability is still king. These are your logs, traces, and metrics. These are still important because these models are very large, so latency is a top concern, block generations and error rates is a top concern, cost is a top concern. So it's important to get all of those metrics back into your system. In addition to traditional observability, I'm going to advocate for 2 solutions to monitoring generations. First is supervised monitoring along your dimensions of concern. This is where it's important that you be able to list what dimensions you care about and be able to evaluate them continuously. So this might look like the continuous evaluation of your quality and safety scoring in production on perhaps a subsample of your data. And then also classifying prompts by task and topic. These are very large models. So they might actually perform, they're not going to regress from your tuning corpus. If the model's stable in production, it won't regress from your tuning corpus. But you may not have all of your data represented in your evaluation corpus. So it might perform poorly on a specific topic or a specific task in a specific topic. And so it's important to classify your prompts by task and topic such that you can really slice and segment the results down to figure out where it might be performing poorly. The other way to monitor generations is to use unsupervised techniques. This is where we translate the generation into an embedding space. We can cluster those embeddings, and then we can determine outlier prompts, and we can also prioritize the largest. Hopefully, the clusters represent common issues, and so you can prioritize clusters by poor scores along your dimensions of concern, whether that's latency, safety, quality. On the customization side, I will mention that tuning is super easy. You only need 100 to 500 examples to supervise fine-tune Gemini. So it's not particularly difficult. If you can build an evaluation set, you can build a tuning set. But again, keep it simple. Only tune once you realize that that's what you need to do. And then also, once you have, there's a feedback loop here, where once you've built up more evaluation data, more tuning data, you'll be able to distill smaller and smaller models. So start with a large model with less data, and eventually that balance will shift, where you'll be able to have more data and get down to a smaller model that's either lower latency, lower cost, or maybe better trained for your evaluation set or your tuning set, because it's maybe data we couldn't incorporate in the pre-training loop. On the augmentation side, I wanted to cover the methods for augmentation really quickly. There's chaining, where you chunk up the prompt and direct it to the best model for the task. There's reasoning loops, where you implement cyclical loops such as react and reflection that are super powerful. Guardrails you'll need to implement for safety. RAG and grounding to give the model access to your knowledge base. And RAG is a space that Google has a lot of experience with in terms of search. And now you can actually ground your models on Google search. And we have some grounding solutions for you. But this is where I think it's a bit more complex than people realize, because a RAG loop can be as complex as 5 to 10 models in and of itself. So if you're going to be implementing a RAG loop and really customizing it, you're going to want to implement intent detection, query rewriting, indexing, embedding, retrieving, re-ranking, filtering, and then finally generating from that knowledge base. And all of that is going to create, some variability in your overall application. Then you want to give the model access to the internet, access to different tools for accomplishing its task, and eventually writing back to those tools. And then you might want to implement routing, where you want to optimize the cost of your inference. So you want to redirect difficult prompts to larger models and easier prompts to smaller models. And this is an optimization technique you want to implement. But overall, this augmentation space and these external agents is going to lead to a Cambrian explosion of models in your enterprise. You've seen that explosion of models outside your enterprise, but if you're building agents at scale, there's going to be way more models within your enterprise. And I actually don't see how you can build agents like this without implementing a very robust MLOps practice. Lastly, on the governance. The most important part of governance is your infrastructure as code and CI/CD deployment pipelines. If you do not have a deployment that is, creating a sandbox is as easy as branching your source code, and deploying to your test and prod environments is as easy as a pull request, then you need to be working on that, because your data scientists and app developers, they have to deal with all the stuff above the line. You need to make it as easy for them to get to production continuously by automating all of that validation. And then I also listed some frameworks here by which you can get some inspiration as far as ISO 42001, the NIST AI Risk Management Framework, and Mos Veritas, and then legislation as far as GDPR, CCPA. Privacy is still super important in this space. Data minimization is still super important. And the EU AI Act, which is coming soon. But overall, I hope that was a thorough review of best practices within the MLOps space. And this is kind of the entire framework. I wanted to highlight, I think we've talked a lot about how generative AI has made MLOps more difficult, but I want to highlight how it's also making MLOps a lot simpler. And all of these spaces I'm highlighting, we're actually using large language models themselves to improve your MLOps practice, whether that's authoring synthetic data, rating results. And so LLMs have made the process harder, but also easier. And you might want to incorporate the easier parts even into other MLOps lifecycles. So how can Vertex and Google help? Well, Vertex has the Vertex AI platform, where this reads from the bottom up. We have Model Garden for discovering models that we curate. We have 138 human-curated models that are both high quality and safe. And then we enable you to easily import from Hugging Face to get that reach. And those are also curated on the Hugging Face side. We have Model Builder, which is the historical Vertex AI platform, allowing you to customize model weights, train them, tune them, and operationalize them. And then the Agent Builder, which is the new hot topic, where you can build agents as simple as in a GUI or build robust agents with point solutions. And so I'd love to map this back to our overall MLOps workflow. And you'll see all these different products where we have out-of-the-box solutions like the Gemini APIs and our Vertex Search. And then we have point solutions where you can do custom training. You can do AutoML is also an out-of-the-box solution, but you can do custom training. You can do vector search. Vector search allows you to do scalable nearest neighbor search. It was innovated here at Google for Google Search by our scalable matching team. It's a very cool piece of tech that you see actually embedded in a lot of our different solutions. And so hopefully through this MLOps tooling, you can really bootstrap your practice. But I think that's enough about theory from me. We have some great customer speakers who will actually talk about reality and how they're implementing generative AI in their practice. So with that, I would love to hand off to Deb from Credit Karma. Deb?
Awesome. Thank you, Chase. Awesome talk. I'm Deb, and I will share you some details about AI at Credit Karma. At Credit Karma, we have been doing machine learning for quite a long time. So we find relevant financial offers for our members using machine learning. We show relevant financial insight, and we reach to our members using notification, all using personalized data and machine learning with deep learning models. For our CK Money product, we make use of machine learning model to understand member risk and prevent assets fraud. So now, how does the MLOps at Credit Karma it used to look like, right, prior to GenAI? So what we have done is that we made use of a combination of custom and Vertex AI components for our machine learning operations. We built batch and streaming feature engineering using BigQuery, Dataflow, Akka, and also Airflow. Feature serving is done using Bigtable. And we also make use of Vertex Feature Store for our content entities. Model training pipeline that we have, they leverage TFX and Vertex pipelines. And we have a customized online model scoring that runs on GKE that makes use of PMML and TensorFlow serving. All of these, our recommendation system, they finally connect with the feature serving and the model scoring services. Now, so what really triggered us, right, to evolve our MLOps for GenAI? Based on the interviews, we found that members, they wanted an always-on financial assistant that provided them with deeper understanding about their finances. Member wanted to ask money-related questions, get contextualized recommendations, and then also get financial insights and discover various features that Chrestkha had. Member wanted a personalized experience with automated reminders so that they can take off the burden of managing all their finances themselves. So to achieve that, how did we evolve our ML platform to support GenAI? So what we did was that we leveraged the standardized data preparation pipelines, which is very similar to our machine learning models. We made use of Google semantic search. I think Chase discussed the Vertex search. We made use of that to give the semantic search capabilities for data retrieval and language model augmentation. We govern all the LLM evaluations and the safety model using standardized ML metadata from Vertex. So now let's go a little bit deeper about the model augmentation. I think Chase mentioned multiple times evaluation. Yes, it is the key thing in our model augmentation flow. So we have various data sources that are in BigQuery, GCS, and PubSub. We extract the data, we create documents out of this data, and we generate the embedding. We index them in vector search. We retrieve all the relevant data for model augmentation using vector search and the data services that we have. Most importantly, we generate and govern all the RAG and LLM evaluation metrics using Vertex pipeline. Now, let's dig a little bit deeper on the language model response generation and monitoring. This touches with Chase's prediction and monitor section, and it's very important for production. So we built a GenOS agent that take member prompt, sanitize it, and augment relevant data using vector search and data services that we have. GenOS is an Intuit-wide platform to build generative AI application. You can find more details in the link that I have. So we make use of the language model to generate the response, and we ensure the safety of it using the guardrails models that we have. Most important aspect is this internal experts. We make use of the internal experts that we have to evaluate this generated response and monitor the quality. We also make use of a third model, a more smart model, to do AI-assisted evaluations. Now, just a little bit of recap. This is what our MLOps at Chrestkha used to look like prior to GenAI. So what are the new components that we added for GenAI? We added the vector search to find relevant data for GenAI application. We introduced language model-powered agent that interact with our member, and it enhanced our recommendation. We evolved our custom ML scoring with language model APIs. And now we are considering language model. We are making use of them for both prediction and generation tasks. Now, to give you a little bit details about the GenAI progress that we have launched our GenAI experience on a cohort of our member. This demo shows you a preview of Intuit Assist, our GenAI experience. It's personalized for our members, and it provides suggested prompts. Members make use of it for credit, debt, money, auto, home, all these conversations. We provide financial insights, and we also give education about finances using our editorial blogs. We recommend relevant offer, and share the context about the recommendation to our member, that why this offer has been shown to the member. So again, I don't have too much time, so please check out the demo offline. It's in the slide, and let me know your feedback. I would love to learn from you. As we evolve Gen AI and in this journey, there are a lot of challenges we faced. One of them is the higher latency and cost. Also, measuring the value for members is difficult. Prompt engineering is quite critical for us, but then again, the tools are infancy for prompt management. So we are looking forward to partner with Vertex to solve these challenges. For our current state, we prioritize GenAI use cases by member needs. We see higher engagement from members who interact with Intuit Assist. Language model response quality evaluation is a continued focus for us. Next, we are ramping our experience to more members and learn from them. Open source language model fine-tuning and also multi-model inputs, they continue to be a focus of investment from us. Thank you, and now I will hand it off to Matt from Wayfair.
Thanks, Deb. Well, hello, everyone. I am what is between you and lunch on the last day of Next. So thank you all for being brave and hanging in there. So Matt Ferrari, have the opportunity, if I can make this happen, have the opportunity to talk to you a little bit today about AI at Wayfair. Hopefully everybody knows Wayfair, but Wayfair's ML journey started back even prior to 2018 with really homegrown targeted use cases. And that worked well for a couple years, but we really quickly reached the capacity of what we could do on our own. And so we piloted Vertex back in right around 2021, picking it for its modularity and its layering with homegrown solutions. Think about it. We couldn't go with an all or nothing solution. We had to experiment. And so that was the real focus. We originally piloted with things like Vertex training and actually saw up to 75% improvements in speed and performance. And subsequently, what we did was we leveraged its full life cycle, which positioned us well for now, for GenAI. And we're currently using things like Palm and Gemini models for a few different use cases that we'll talk about here in a moment. Vertex has been a really, really strong modular platform that we've been able to extend on. With GenAI, with the early days of kind of Wayfair investing, we took a similar life cycle view, which is evolving really fast, with the initial focus on model selection and evaluations, and then repeatability for our science teams to build on those foundational models. Beyond that, what we did was we developed pilots with Gemini for things like code generation and code assistant for our engineers, and we're seeing great results there. So here's an example of our predictive model today. I'd love to talk about every single line, but we certainly don't have time. Wayfair has continued to adopt the majority of services in Vertex AI, and we continue to do so. Yes, you can see some names you probably don't recognize up here, because what I wanted to show is we absolutely still have internal platforms that remain. And as Vertex AI continues to grow in feature capability, we're transitioning those to Vertex services. Specifically, we built around Vertex Feature Store, which had enabled us to lessen the investment in our feature platforms, enabling our scientists and ML engineers to directly manage features that are being integrated in things like BigQuery, Vertex Training, and Predict. We're also investing in the experience of the platform in conjunction with our ecosystem so that we can focus on delivering things like SDKs and libraries on top of Vertex that differentiate Wayfair. And that's really greatly simplified our lifecycle for all of our predictive models. Some of the things that Vertex has allowed us to do. It's allowed us to really pilot, almost fail fast, right? Pilot early models, testing across multiple fronts. You can see some experiences up here, and candidly, I'd love to talk to all of you about them. It's also helped us create new content, code, imagery, simulations, videos, all designed to try to drive best-in-class experiences with human in the loop as a focus. And sometimes it's meant to, we're doing it by delivering things like OSS models, though that gap is narrowing, as hopefully everyone saw this week, but still leveraging our ML ecosystem on top of GCP. Examples up here, I'll just pick one. Things like Decorify. If you haven't read about it, picture the ability to see your room and the in-home experience of putting something from Wayfair in the room that you can design in a virtual environment using ML models and Vertex AI to actually deliver it. Pretty cool. As we began to invest in the GenAI experience, we had really 3 principles in mind. First one, privacy and security. We work closely with Google to ensure that our IP and customer data would not be used in model training. Certainly a concern walking in the door from a lot of you, actually. Second, education and experimentation. Learning how do we use LLMs beyond just kind of like the initial zero-shot prompt enabled us to achieve results and increase confidence in the models and really get our scientists to buy it. Third, how do we scale the platform for all types of use cases without overbuilding and leveraging what is available from Google already today? So today, core set of capabilities, we think about it. Our current work is centered around productization of the early proof of concepts and successful experiments. We're also focusing on how can we have greater reuse of prompts and prompt engineering, pipelines and vector embeddings. And we're using patterns to do things like decompose to improve response quality. Wayfair has thousands of applications that are in some kind of tech transformation format right now, and we're leveraging Vertex for a lot of that. And finally, we're bootstrapping a few core components, things that you would know like context manager or grounding truth for LLMs, or prompt manager, which we're using for things like reusable prompt libraries, or even an LLM manager, which is focusing on solving for model selection and best cost to performance ratio. So what's next? We think about what's next for Wayfair. It's focusing really on customization and optimization in both of our use of specific foundational models, patterns like retrieval or RAGs, and fine-tuning. And we see opportunities to both continue to reduce latency and cost by establishing more of a model evaluation offering. Really trying to focus on how can we let scientists do science. Code generation for internal transformation along with targeted customer experiences have also given us a solid foundation to build upon. However, there's a lot of use cases that are still untapped. And so while Wayfair today is focused much on what we call tech transformation or code transformation, code optimization, the truth is some of those use cases that you saw on the previous slide are now around changing the customer experience by using Vertex and GenAI. And that's what's to come. With that, I'm going to turn things back over to Mikhail. Thank you all.
Great. Thank you, Matt, Deb, and Chase. So I'm going to close this out, and I'm going to actually use the help of our friends and top data and AI services partner, Datatonic, who I actually got to meet face-to-face. And really, I want to focus again on real-world implementations, similar to what Wayfair and Credit Karma just walked through. So again, while we're still early in the generative AI era, Datatonic is another example with its clients and another proof point of the fact that generative AI apps are moving to production. Datatonic, again, has delivered 40+ generative AI projects in the last few quarters on GCP and Vertex AI. Yesterday, they actually presented with Liberty Global on how they built an intelligent invoicing matching solution, cutting costs by over 70% using generative AI. I also got to meet with one of their clients, the Cineverse team, yesterday, where they're leveraging Vertex AI for generative AI search and discovery for personalized video and media entertainment. And these are two examples of really focusing on a core critical use case within an organization and taking them from POC to production. But the other second pattern that is emerging that is very similar to what Deb and Matt just presented on is extending their work with clients on their existing AI platforms. Datatonic over the last few years has helped customers like Vodafone, British Telecom, Telia, and others to set up an MLOps platform on GCP for predictive AI, and now using that platform for generative AI use cases to scale in a secure manner. Now, this approach for enterprises has a lot of advantages. It really, again, builds on the AI platform and MLOps investments many of us made in the last few years, and is able to accelerate your path to production for newer generative AI use cases. Now, there are, of course, key differences between predictive AI and generative AI, but I love the diagram from Datatonic that really portrays what you can actually leverage. In green, we have a lot of the similar needs between both paradigms of AI. Workflow management, API integrations, CI/CD, data security. And in gray, we can overlay some of the newer elements like prompts, guardrails, retrievals, and vector DBs. And this, again, aligns very well with Vertex AI, where we're really committed on a single platform for predictive and generative AI workflows, tabular and unstructured data, open source or fully managed model APIs, because many of the underlying governance and deployment needs really remain very similar. So to wrap this up, here's a quick summary. Again, number one, really start getting familiar with frameworks and really workflows and guides. And I promise you, for those who want to chase more time with Chase to really walk through that framework, we're really going to push to get a detailed guide out there, walking you through that in more detail. Second, we have seen actually customers integrate popular tools around Vertex AI to accelerate development even more. We see a lot of customers working with Snorkel and Labelbox to help curate and fine-tune data. We see customers working weights and biases and Arise on top of Vertex to help with monitoring, troubleshooting, and observing those LLM responses. And of course, LangChain and Llama Index to help developers power data-powered LLM apps with great integration with Vertex. And finally, again, real-world customer implementations. We're going to continue to showcase that with you. I'm personally excited to sift through all the content that really was out there in the last 3 days to show how our customers are really getting that first wave of generative AI use cases over the finish line and how we can really build on that knowledge as a community. For those that are not too familiar with GCP and Vertex AI, please scan this code. We'll have someone from our team reach out to you. Maybe give that about 2 seconds. Again, a few suggestions to watch on demand. I know it's day 3. A lot of these sessions that we referred to will be available on YouTube on demand over the next few days.